Hi guys, welcome. Let's make sure we're live. Today we are doing lesson 101 and 102. So we're week 9. There's just 2 lessons this week again. So let's go ahead and flip over to lesson 101. We're looking at geometric probability in this one. So again, geometry, we're working with shapes, polygons, circles, things like that. And then thinking about probability, areas within areas. So if you think about the bullseye on a dartboard or target, the further you go inside, the lower the probability comes of hitting anywhere. Pretty good probability. Hitting, the smaller and smaller and smaller, the probability of hitting that is going down. That's why some of these archers or dart players or marksmen, people that shoot these targets with whatever, the further the distance and the smaller the target, the more skill you have to have or get really, really lucky. So if a 12-inch diameter target is hit, what is the probability that the 4-inch diameter bullseye is hit? So again, we're assuming that the target's hit. I'm not talking about the probability of hitting the target itself. So assuming that we're going to hit the target, what's the probability if we hit the target that we also hit the bullseye? Right, so we're looking here, area of the target, area of the bullseye. We got to find those, and then the area of the bullseye over the target. Okay, that'll tell us the probability of getting a bullseye. And we go over. So the diameter was 12 of the larger. So the radius we know is 6 of the smaller. The diameter is 4, so the radius is 2, and it's in inches. So we want to know the probability of the smaller region over the larger region. So area of, let's look at the smaller, the circle, pi r squared. R squared, 2 squared is 4, so that's 4 pi. Larger region, pi r squared. That's 36. 6 squared is 36 pi. Okay. So we have the smaller over the larger. We know, obviously, probability. If it's certain to happen, it's 1. If it's impossible, it's 0. And then probability falls everywhere in between. Pi over pi cancels out, and then 4 over 36 can reduce down to 1 over 9. And then if we wanted to express it as a decimal, it would be about 11.11, because it's going to repeat forever, about 11%. So again, closer to 0, but it's still obviously possible to do it. So it's not always going to be a bullseye, a circle within a circle. We can have a triangle within a square, or square within a circle, or whatever. So geometric probability, and we want to know the area of the specific region, shaded, smaller, whatever they're indicating it with, over the area of the known region, or the larger. So if we're looking here, and we have a circle with a diameter of 20 and a 10 by 10 square, what is the probability that an object that lands in the circle also lands in the square? Okay, so the diameter we're told is 20. So radius is 10 because it's half of 20. Then this is a 10 by 10. So let's look at the square. Side squared or side times side. 10 times 10 is 100 square centimeters. Okay, that's a smaller region. The area out here, pi r squared, 10 squared is 100. 100 times 3.14 is 314. So 100 over 314 equals 3184, and continue on to two decimal places, so we'll call it 0.32. So 0.32, about 32%. Again, it continues on. My calculator has it out to 9 decimal places. I don't see it start repeating. It's got to be rational. But anyways, we'll round it to right there. All right. So the practice set we'll go over together in class and look at those different shapes. Again, the smaller region over the larger region. That's geometric probability. So be working with areas. We've done that since the beginning of the year. You guys should be solid on that. And then probability we know is going to be between 0 and 1. Okay, and then the other lesson we're looking at for this week is growth and decay. So again, if something's growing, it's getting larger. If something's decaying, it's getting smaller. So we see examples of growth and decay in the financial realm. The effect of compound interest on the value of a bank account is an example of growth. We want our money to grow over time. The effect of inflation on the value of the dollar in the world market is an example of decay, because the value of the dollar is going down. If something costs $10,000 today and $50,000 a week from now, the value of the dollar is going down. So example 1, the population of a county has grown 2%. So we're growing. We're up by 2%. Per the last 5 years, if the county's population is now 1.2 million, what will the population be in 3 years at the current growth rate, round to the nearest thousand? Okay, so how we're going to set this up. And so we're starting at 1.2 million, or 1,200,000. It was 2%, so 2% we want to, again, make it a decimal. So move decimal 2 places to the left, so 0.02. Now 100% would just be 1. So really, we're thinking that this is 102% of the previous year. If it keeps going up by 2% each year, we need to figure out 102% of that, or this is a decimal B. So we add 1 to this, or think of it in terms of 102%, move the decimal. So this is what we want. So year 1, we're going to do 1.2 million times 1.02. And we get 1,224,000 is our new population. And then after 2 years, now this is our new population. So that's where we're going to start. And I'll show you on the calculator so we don't have to keep redoing it. So that's where we got that number from. Now we can just do that, drop down our answer, either punch it back in or just hit the times, and then it'll pull that answer down there. That's what that means. It's our previous answer. Times 1.02. So there's year 2. Times 0.012. and it's going to keep going. We were asked for after 3 years. Okay, so that was 3 years. Another way we can do this is we can say our starting point and then we can raise this to whatever year we want. So we can use this starting point times how much we're going up each year, and then our exponent would be number of years. So after, what did it ask? We weren't asked to find 10 years, but if we put in 10 years, there would be our new population. Okay, so we can use exponents to graph this and kind of see the trend and save us a little bit of time versus doing year 1, 2, 3, 4. Because if we want to take it out 20 years, using the exponent, we could just put in 20 versus doing this 20 separate times. Okay, and the rule of 72, as I talked a little bit about, after 3 years, the county's population would be what we just found, dividing 72 by 2, the growth rate percentage. We find that the population would double in about 36 years at the current rate. Again, populations, people move into areas, move out of areas. Obviously, globally, overall, the population is going up, but again, at that rate, it takes about 36 years to double. Carbon-14 is a radioactive isotope occurring in nature. It's used to date materials, so you've probably heard of carbon dating. That's what this is. Such as once living plants and animals, carbon-14 has a half-life of 5,730 years. If a bone is found containing about 1/4 the amount of carbon-14 as modern-day bones, about how old is that? So we have A, 11,000, B, 5,500, and C, 2,700. Okay, well, 1/4 is half of half. So 5,500 would almost be half of it, but there's only a fourth, so we need to do a half of a half. So that's 2 half-life cycles. So it'd probably be almost double this, which A, 11,000 is going to be the closest one to that. All right. So that'll be it for this week. Lesson 101 and 102, we'll go over those practice set problems in class.